Hello, hello. Yes, I will welcome you back again to PSSB, Physical Sciences Silver Bullet. It's Richard once again. So today we are looking at this question. It's a grade 10 question, but we can make use of this information in higher grades. It says that aluminium trichloride are hydrated crystals represented by the formula. So this is the formula. And the question says, what is meant by hydrated compounds? So hydrated, hydration, water-related. What does it mean? Hydrated crystals means compounds or crystals which crystallize with water attached to it. That's what is called water of crystallization. So in other words, it is the one which has water of crystallization in it. That's what we call hydrated crystals or hydrated compound. Okay, then we come to this question, 3.2. The question says that 5 grams of hydrated aluminum trichloride was strongly heated until all water is evaporated. The final mass was found to be 2.8 grams. So the question says, state the observable change in the texture of aluminum trichloride. Okay, here you have to remember that these crystals, if you want to know what crystals look like, you have to look at what sugar is. These crystals are in that texture of the crystalline structure because of water of crystallization. Once the crystals lose water of crystallization, it loses the crystalline structure. It either becomes powder or amorphous. So what is the answer? The answer is that the crystalline structure is lost. So that's the answer. It ceases to become crystalline. So that is that. The compound lost its crystalline structure. So we go to the next question. Yes, then comes this question, 3.22. It says, determine the value of n through calculations. Okay, how do you go about this? Then this is what you have to assume. Remember, we had 5 grams of the hydrated sample, and it was heat for some time, and the mass reduced to 2.8. So in other words, what does that mean? It means that during the heating, water of crystallization was dislodged off the crystal, and the crystal lost its crystalline structure as well as also the water of crystallization. So in other words, what remains behind is the aluminium chloride without water of crystallization. and that one is 2.8 grams. So the question is, how much water is lost? H2O lost is 5 grams minus 2.8. You get 2.2. So these are the number. This is the mass of water which was lost. So 2.2 represents the mass of water of crystallization in the sample. So what do we do here? You do the same thing. So this time around, you have your aluminium chloride, and we know its mass is 2.8. And this side we have water of crystallization, and this mass is 2.2. What do? You find the molar mass of aluminium chloride. It is molar mass of aluminium trichloride. It comes to 27 plus 35.5 times 3. This one gives you, yes, it gives you 133.5. Okay, let's look at this side. This side, we look for the molar mass of water, which is supposed to be 2 plus 16, giving you 18. So what do? You divide the mass with the molar mass. It's going to be 2.8 divided by 133.5. This time around, this side we have 2.2 divided by 18. What do we get? So this is what we get. Next step, you divide by the smallest. So it's going to be 0.021 divided by 0.021, and this side is going to be 0.122 divided by 0.21. So after dividing, you get 5.8. So our n is supposed to be a whole number. So if it's 5.8, we say it's approximately 6. So our n is 6. Thanks for that. So let's see what comes next. Then comes this question 3.33. It says calculate the percentage composition of water of crystallization in the aluminium trichloride. Okay, where do we start with this one? You have to remember previously that we know now the actual formula of the crystal, of aluminium trichloride crystal. It is aluminium trichloride 6C water. Remember, we determined the N, which is the water of crystallization. So that's the formula. So with this formula, what are we calculating? We are calculating the percentage composition of water of crystallization. So in other words, we are determining the percentage of this. So how do you approach that one? You're going to say mass of water of crystallization over mass of let us say over molar mass of the crystal. So times what? Times 100. So what is the mass of water of crystallization? We know that water is 18, so it's going to be 6 times 18 over total mass over molar mass of the crystal, which is. So that's what we get. It is mass of water of crystallization over molar mass of the crystal. So what you get after computation, because we have 6 moles of water of crystallization, so it's 6 times 18, then you divide by the total molar mass of the entire crystal, including water of crystallization, and what you get is going to be 44.72%. So that's the end of this video. We thank you for subscribing. If you have not, please do so. And we will appreciate if you interact, you comment, you refer a friend. Okay, thanks very much. We will see you in the next video.